In this video, I want to discuss mixing applications for gates. I'm going to open up this Expander Gate plugin here on the bass track. Now, a gate allows an audio signal to pass through it if the signal is above a specified volume level. When the signal is below that level, the gate is closed and the signal is attenuated either partially or fully. Gates are used to allow the desired or louder signal to pass through while denying unwanted softer signals. They're good for eliminating unwanted noise on tracks, like guitar amp hum, as well as creating cool effects like cutting off reverb tails and making click-triggered pulses. Let's listen to an example here. The gate is used to cut off the sustained notes on this bass track. As you can see, any part of the signal that was above this threshold line wasn't cut off, but once it fell below this threshold, it came down into this area and was drastically reduced in volume. Now, what happens really when you have a gate on a track? First, the signal comes into the gate, and the gate inspects the signal and decides whether it's above the threshold, and that threshold is this line right here. We set that down here. If the threshold hasn't been crossed, the gate remains closed and blocks the signal from going to the output. However, if the signal crosses the threshold, the gate opens up according to the attack speed, which is right here. The gate stays open for a specified amount of time, for the hold time, and then closes if the signal has fallen below the threshold volume at a speed selected by the release parameter. The range parameter on a gate determines how much of the volume is reduced on a signal that moves below the threshold. The lower the range value, the less volume the gate allows to be heard. So as I twist this, you're going to see this line move. If I bring it all the way down, then the gate is not going to allow any signal to come through once the gate is closed. But if I raise this up, back to where I had it before, then when the gate closes, you can actually still hear a portion of the signal. When you allow the gate to let through some of this volume here, that actually turns the gate into what's called an expander. And gates with medium to high range values from -40 to 0 dB are called expanders. Now, where gates are useful for eliminating unwanted noise between musical sections on a track, downward expanders like this are good for simply lowering but not entirely eliminating the noise. Expanders and gates basically have the same parameters, except that expanders may also have a ratio parameter. That's down here. On a gate, the ratio is extremely high. However, on an expander, you can actually turn that down and you'll see the line up here decreasing in its slope. The ratio in an expander works in the opposite way as a compressor's ratio. Once a signal falls below the threshold, this line here, the ratio pushes the signal lower than it would be without expansion. This may sound a little strange, but if you think about it, expanders actually expand the dynamic range of a track by pushing the signal level lower when it's below the threshold. Now, I actually prefer using downward expanders instead of gates in noise-reducing applications because the level changes aren't as drastic. They just sound more musical to me. Now let me give you some notes about gates and expanders. The attack time. You should use a fast attack time when you're gating drums so that the initial transients aren't gated. So you just bring this way down. However, you should use slower attack times on lower frequency instruments. In this case, for our bass, we wanted the attack time to be a lot higher. And the reason for that is fast attack times might distort low-frequency tracks by quickly raising the gain in the middle of a wavelength. This can cause unwanted clicks in the track. Now, short release times may unintentionally cut off the ends of notes, so use longer release times for more gradual fades.